Hi, everyone. Welcome to the Paradigm Podcast. Today, we're joined by Professor Bhaskar, and he's a really special guest because he teaches at the USC's Viterbi School of Engineering, and he teaches distributed systems and the Internet of Things. But his work goes much deeper than that, spanning how large-scale networks, smart devices, and increasingly AI systems interact in the real world. He's also been on this podcast once before, but a lot has changed in the past few years, and I'm excited to have this conversation with him from my perspective as a student, I think, in this ever-changing technological landscape. So yeah, thank you so much for joining us.
Glad to be here.
Let's get straight into it. Could you give us a brief introduction of yourself and what you do on a higher level, and then maybe also a certain niche that you've been obsessed with recently?
Sure. So I tell people I work on the ABC of emerging technologies, so AI, blockchain, and connected cyber-physical systems. And I think of this as really quite a broad set of topics because it covers sensing, communication, computation, and intelligence, and ultimately sort of control. And doing all of these things with some notions of security and privacy built in. So it's kind of like a broad landscape. I would say, things that are more interesting recently, we've been working quite a bit on networked computation, where the computation isn't just happening in one location, either in the cloud or on your device, but sort of leveraging wherever there are computation points. So it's maybe a little bit more on the technical side, but on the more practical side of things, I think I've been getting very interested in questions of safety and privacy preservation, and ultimately, like, how do we get technology to work for us and help us?
Yeah, that makes so much sense. And kind of what originally pulled you into this space? Was there a moment or a problem that hooked you early on?
I want to say there were like two different things. I'll see if I can
Mm.
quickly cover both of them. One was when I was in undergrad, I read this book by Richard Heinlein, and um, and it was a book that talked about a computer network on the moon that becomes sentient, becomes aware, and something about that combination of networks and AI really, I think, sparked something in me. But years later, when I was a grad student, I got a chance to work with an amazing group at Berkeley, led by Professor David Culler. And they were working on this, what was then an emerging technology called wireless sensor networks. And with these like little embedded devices that have sensors on board, radios to communicate, a little microprocessor. And they had deployed it in a very cool application that just thrilled me. As you know, I'm very interested in birds,
Yeah.
and this particular application was for field biologists that were studying a species of bird off the coast of Maine called the Leach's storm petrel. And used to be they would, periodically, maybe once a year, go to this island, stick their hand into burrows, pull out a bird, and check off a box and saying bird found and put the bird back in. But with these wireless sensors, they could just deploy them in the burrows, and through the humidity readings, the temperature readings, they could get a 24/7 readout of when the burrows were occupied, and they could get all of the sort of rich information about their lives. And I thought the application was absolutely fascinating that you can, collect this sort of useful information in such a fine grain at scale. And I think that's sort of probably one of the hooks as well for me to get into IoT and related topics.
Yeah, I think like having hobbies and then seeing that in a technological landscape can also like really hook you on.
Sure.
What's the kind of timeline? When did you like go to, did you do your undergrad and then grad school?
So I went to an undergrad school called Cooper Union. I was there till 98. And then I went to Cornell to do my master's and PhD. And I was there till 2002. And since then, I've been at USC.
Wow, that's really cool. And when you started, what do you think were the hardest problems? What did the field look like pre-smartphones and cloud?
Yeah, it's really interesting. At the time, I think we were most concerned about resource constraints. So we would look at, how do you do these things with limited batteries, limited storage, limited compute power, limited connectivity, unreliable wireless systems. And I think a lot of that has changed since. Right now, we take for granted cloud computing. We have incredible wireless connectivity wherever we are due to 4G and 5G. And so, yeah, a lot of ways in which the field has changed.
Yeah, no, I think that's really cool. I remember I was on a hike a couple days ago or actually a couple months ago, and my cousin had like the Starlink,
Mhm.
and we were able to send a text when there was
No matter where you are, it's
yeah,
so
like no
crazy.
matter where you are. So I think that's crazy, and I think my generation really takes that for granted.
Mhm.
And I remember in class you were like, oh, maybe it was your class where you were like, oh, you guys just like send a picture without realizing like the compression, and like back in the day you weren't able to do that. So yeah. Um, and when do you think in your career did this feel like fundamentally shift and when the questions themselves changed,
I
right?
think in the 2010s, really, the last decade and a half or so. And it's all of the things we just talked about, right? Mobile devices became so much more capable. One of my colleagues calls it a supercomputer in your pocket.
Mhm.
And then we have cloud computing with incredible amounts of compute capabilities. The development of really powerful AI models more recently, but they've been, in development for the last decade and a half in many different contexts. So I think, yeah, all of these things have really changed the landscape and the types of questions we can ask. And at the same time, like new technologies keep bubbling up. So yeah, it's very exciting.
Yeah. And kind of switching gears into IoT, it's been hyped for years. Where do you think it has actually delivered and where hasn't it?
Yeah, so IoT, the Internet of Things, a lot of people are a little, unsure about what it encompasses. For me, if you have a system that has sensing and communication and computation, maybe some control in it, it is an IoT system. So it shows up in places where we don't necessarily think of it as an IoT application. The one I like to tell students about is Uber. Right, you wouldn't be able to hail a ride from anywhere and get matched with the nearest rider if there wasn't a sensor in both the passenger side and the driver side, which is the GPS unit. And there's a lot of communication of that information, some computation to match the rider with the passenger. So there's places like that where IoT is already really in our lives and we barely think of it. The Ring camera is another good example. It's also in a lot of industrial use cases and really delivering a lot of value for things like fleet tracking, for supply chain logistics, for industrial sort of condition monitoring of factory equipment. And also even in farms, actually, for precision agriculture, putting soil moisture sensors that tell you when's the right time to water your crops or when to harvest. So they are delivering a lot of value, but sometimes a lot of these use cases, maybe it's a good sign, they're sort of so integrated into what people are doing already that it sort of maybe doesn't strike us as a cool IoT application per se.
Interesting. Yeah, and what do you think? What is something that engineers constantly underestimate when building large scale IoT
I
systems?
think there is a big gap between sort of small use cases of IoT and large scale systems. Often, the hardest part about a large scale IoT system is when you cross administrative and political and economic boundaries. So we had a big project looking at how do we scale IoT to the level of smart cities. And if you want to deploy an IoT system in a smart city, well, first of all, let's take like LA County. We've got something like 80 plus cities in LA. The city of LA, which is one of those 80 some cities, has like 18 different agencies. Every one of them is capable of kind of deploying a prototype of one IoT application or the other, but they won't talk to each other. Because they kind of cross some administrative boundaries. You might have one system, kind of procured from one vendor whose protocols are not interoperable with the protocols and systems of another vendor. So how do you kind of scale these things up so devices from different vendors can talk to each other? Somebody who wants to build a new application for the city can figure out how to get data from all these different existing sensor deployments. So these are kind of a different type of challenge that you don't encounter if you're just building one IoT system for one
Mm.
application. So that's something that has not yet matured, and I think will still take some time.
Yeah, and I remember you were talking something about LA doing a project um, relating to like finding parking spots.
Mhm.
Can you talk a little bit more about that? I
Sure,
think
yeah,
it's
that's a
really
concrete
interesting.
example of exactly this
Yeah.
challenge. So if you think about, wouldn't it be cool if you're going to meet someone downtown at 2 p.m. this afternoon that you know exactly where you would find parking, maybe even register in advance and pay for it before you even show up, right? Well, today that's a close to impossible task because the number of different types of parking solutions vary from like the city meter parking to private garages. Like the airport has its own parking system and so on. And you can get data from those different sources in one place. And so the system that we were kind of prototyping and doing a proof of concept demo with the city of LA was basically, can we gather together all these different sources of information on a single platform that the city would help coordinate, but ultimately a third party application developer could tap into and say, I've got all these different sources of data about parking. I can pull them into my app and I can make it available to a user. And so again, it is one of those things that just like crosses so many different like organizational boundaries. But if we could build such a system, it could really help accelerate that.
Yeah, and I think that really shows how important data is. And no matter how advanced the technology is, if you don't have the right data, I think it just doesn't work. And your work also looks at putting AI directly into these IoT systems. Why do you think that matters, and what makes it particularly hard?
I think, well, first of all, there's just a very natural connection between AI and sensor data because AI can help us make, not really a pun here, but make sense of the data from sensors. Um, Process it, make inferences, detect what's happening, make even some decisions based on the current sensor data in that environment. So in that sense, there's a very natural connection. There is this question of how do we make our devices more intelligent so they can serve us better, so they are faster in the loop to kind of do something that we need. But also, if we can bring intelligence closer to where the data sits, we can have potentially more privacy. Things can be more secure. We can have also less data that needs to be shipped from one location to another that can save on bandwidth when that's scarce. Yes, a lot of reasons to kind of explore that intersection between sensing and AI.
Makes sense. And from your experience, pre-AI versus now, has there been like a visible difference the in the like IoT applications that you've worked on? Is
I
there
think I think now we take for granted that we can process that data in a much more intelligent manner. That we can improve the quality of our um, detections or inference because we can use the AI kind of in a loop to improve itself. So I think that's still an ongoing effort in a way because at the same time, many of our current strongest AI models are extremely compute hungry.
Mhm.
And so they have to be deployed in very powerful cloud servers, which may not be available at the edge where the data sits. So there's still kind of an open question of how do we make it all work from an engineering standpoint. Yeah.
Makes sense. And this is kind of, I don't know, a vague question, but if you rebuilt the smart home from scratch today, what would you do differently?
I think, the real opportunity now is we can build IoT systems that are very customizable and reconfigurable because of the quality of intelligence that we have at our disposal. So the way I might want my smart home to look might not be the way you want your smart home to look. And the way I want it to be today might be different from the way I want it to be 3 years from now. And so, could we build systems that are very easy for the user to kind of configure on the fly and say, I want this capability, I want it to work in this particular way to help me? Whereas I think the way we've traditionally thought about IoT systems is it's kind of a cookie cutter design. What I put out there in the market is what everybody has to put as is. And in fact, that's what's probably impeding their deployment too, because every individual has a different way in which they want to see technology help them in their home. So I think there's a real opportunity there to kind of rethink what it means to have a customized engineered IoT system that's serving you, right, in the ways that you want it to.
Makes sense. And do you ever think that people are becoming too dependent on smart home devices?
I think absolutely true.
Yeah.
That's definitely true. I think people are initially motivated by the coolness factor and the convenience. But it's also true that often, and I'm thinking about just our smartphones and doom scrolling, right? Often there's just content there, and the algorithms are designed to hook us in such a way that they are kind of pulling our attention into the use of this technology.
Mhm.
And there's this fine line between where the technology is bringing us joy, connecting us with people, giving us information that we want, educating us, and kind of capturing our attention in a way that is not serving us, that is actually disconnecting us, that's maybe, um, you know, uh, affecting our sleep. It could be, any number of issues like that. And so I think I I don't have a quick answer for it, but
Yeah.
I think it's very much about, to some extent, our own mindful use of technology, but possibly also societally, collectively, thinking about what regulations need to be in place. So, for example, recently there's been a lot of move in various school districts
Mhm.
to not allow phones in the classroom. And I think that's an example of where, people have put some thought into, is this helping us or is it not? And maybe it took us a while to, figure
Yeah.
that out. But I think those types of conversations for ourselves, within our families, in our society is very important.
Yeah, and I think I can speak from experience. I went to school in India for 10 years and we weren't allowed to bring smartphones. And I think back then my attention span was a lot better than it is today,
Mhm.
having my phone on me 24/7. And obviously it's convenient, to like read news when you're bored, stuff like that. But also you can get addicted very soon. And then also being dependent on kind of smart home devices. I remember when the Amazon, or like the cloud, like a thing went down, there was this like article where so there's these like smart heaters in the beds,
Mhm.
and like when it's too cold, like you can set it to like a certain
Uh-huh.
threshold and then it gets heated up or then it cools down. And this like one family, their beds got really hot when
Oh
the
my
thing
goodness.
went down. So I think that's just like, it's sometimes people get overly dependent,
Sure.
and that just goes to show that. And then also, my friend was telling me that they have Alexas in like each and every room in their
Mhm.
house, and when their mom like wants to call them for dinner, she just like tells Alexa to like send a message to every
Room
device
so
in
they
the
can,
room.
yeah.
Yes, I just think like kind of where's the boundary there?
Yeah. I think absolutely that's, something that many individuals and families are grappling with, right? Since the technology has become so pervasive. Um, I think, to me, the core of this is like, why are we building these technologies, right? So the hope is always that they bring us joy, they make us safer in some way, that they are improving our health, that they're bringing ease and convenience. And all of this is ultimately to help us thrive. And I just think that we get caught up in some aspect of this technology and kind of lose sight of that picture, right? And to me, that question of like, how can we get technology to make us thrive, is not just about the technology. It's also about our response to it and how we use it and how we talk about it with others, and what kind of things we have in place. And sometimes the solutions can be technological. I have this little device called the brick,
Mm,
which is an IoT device where you can go tap it. It's like just a very physical little device. You can tap your phone on it and it'll basically disable applications on your
I think
phone for
I've
a
heard
period of
about that.
time.
Yeah.
And it's a very funny thing, but I basically put the brick downstairs and I sleep upstairs. And so in the evening, if I, remember to turn off my apps at the brick downstairs, I have a lovely night of sleep. It's just, I'm not on my phone.
Yeah.
So sometimes there can be like little, things on the side where technology can help us be more mindful
Yeah.
of its own use. So,
Yeah. I think like my generation is obviously really addicted, but then there's also people that are trying to make active effort to kind of get away from that addiction. There's apps that like force you to take a second to breathe before you
hmm
open the app. And I think I've seen my friends who open Instagram constantly, and then every time they open it, it says, take a second to breathe. Are you sure you want to open the app?
hmm
And I've seen them like close their phone and like go back to studying.
hmm
So I think there's a lot of awareness around that too recently, which has been really good. So yeah, kind of steering away from this conversation, I want to talk about decentralization and trust. People hear blockchain and think crypto, but you use it to help devices coordinate without a central authority. So why does that matter, do you think?
So the idea at the core of blockchain technologies is decentralizing systems so that you're not relying on one device or one entity or one organization to control everything. And there are many use cases where that brings greater transparency, freedom from manipulation, censorship. and increases the security of the system if one entity can shut down things or even can be hacked into shutting down things. So it can be really a tool for enabling decentralized trust, more transparency, auditability of transactions in certain use cases like supply chain, being able to kind of know exactly who handed over the product to whom at what point in the supply chain can be very useful and important. So I think there's a number of use cases where it is allowing us to have an architecture that's harder to manipulate in negative ways.
Makes sense. But I'm not really familiar with the blockchain space, but aren't people still able to hack these contracts?
Yeah, so I think that's also a part of working with new technologies is that sometimes when it's new, there are still vulnerabilities that we haven't even figured out yet. And sometimes it's not the core conceptual algorithm, if you will, but the particular implementation of it has a bug in it or has some vulnerability. And blockchain systems, for better or worse, a lot of their initial use cases have been in the world of finance and cryptocurrencies, with a lot of sort of monetary value at stake. And that has brought in a lot of bad actors who are looking for ways to hack these systems, detect those vulnerabilities to be able to steal. And so, in a way that's bad because there are vulnerabilities and a lot of financial loss associated with it. But on the flip side of it, every new vulnerability that gets exploited is also a signal to everyone else to improve the security of their systems. So there's always a bit of an arms race between, the vulnerabilities getting detected and new defenses being put together. In the long run, I'm optimistic that we get better and better at securing these systems, including with the use of some of the AI tools that are emerging. So,
Yeah, that's very cool. I actually worked at a Web3 security startup last summer where we try to build a multi-agent system to find vulnerabilities in these
exactly.
smart
Yeah, that's a
contracts.
fantastic use case
Yeah.
for,
Yeah, and it was actually really cool. I was able to find the vulnerabilities, run the exploits on chain,
Mhm.
and then help these startups audit their contracts because
Exactly.
it's
Yeah.
very expensive for them to do that. And
Yeah,
I
and in
think
fact, in some of my experiences also, typically people used to get their code audited by sort of human
hmm
audit teams, and they would occasionally miss something that was quite significant. And some of these new AI systems are much better at detecting the software vulnerabilities.
yeah, and sometimes there are auditors that are better at finding these vulnerabilities, but I think like having these AI systems like gives them a helping hand
Definitely.
and like a starting point in doing so. Um, Yeah, and then moving on to sort of the ethics of things. So who should actually own the data that our devices generate? Do you think it's like us or the companies or someone else? And even in the blockchain scenario, like who would own the data sort of?
Yeah, I think sometimes the word ownership is a little tricky
Mhm.
because, unlike a physical object, I can't just put my hand on it and say, I've got it, right? And data in particular is very easy to make copies of, can be stored in many different ways. But I think my starting point would be that if the data is about me and concerns me and is something that I consider private and personal, then I should have the right to give consent about when it's used, how it's used, by whom it's used. And so I feel like that's really important to have these sort of consent policies, and they should be opt in, not opt out, right? Like you shouldn't find out years
Yeah.
later that you just had access to all this data that you didn't realize. But sometimes it's also very tricky because how many of us haven't installed some application and there was that screen that says agree at the bottom and we have no idea what it just said. We just
Yeah.
scrolled past it, hit agree, and moved
There's
on.
so much
What do we
terrain.
just agree to?
Yeah.
So sort of simplifying some of the legal language around
Mhm.
consent is very important. I think today's AI systems might do a better job of helping us figure out what we are agreeing to or not, and when we are consenting, what the implications are. Um, but also sometimes it's not easy because maybe you're agreeing to do something that lets you have some utility from the system. But on the flip side of it, in order to get that utility, you have to give up something.
Mhm.
But at least to be able to think through some of these trade-offs individually and collectively, it would be helpful to have more transparency about what we're doing in this space.
Yeah. No, I think it's very helpful to be aware of where your data is going and how much data is being stored, etc. I wanted to get your thoughts on digital footprint and Palantir recently. Also, there's been a lot of stuff going on with Anthropic versus OpenAI and the Department of Defense. So just like speaking on that in terms of ownership and security and data.
Yeah, I think I don't have good answers for what are very challenging and broad questions. Um, in a way, our use of digital technologies, because data is so easy to capture, to transfer, to communicate, and because of how omnipresent, right, sources that can collect data about us are, very classic example is we have our phones in our pocket and they're emitting Bluetooth signals, which are basically, in many cases, advertising some type of identifier. And they can be used to basically log our interactions, our locations over sustained period of time. Sometimes in ways that are useful to us, like sometimes people like to have that Find My iPhone feature and to be able to figure out where they sometimes even where your friends are, right? Or where your AirTags are, where your wallet is, etc. But the same type of data has a lot of other use cases again that you would not consent to had you known, right? This is what was happening. Um, I guess there's a part of me that has some optimism that we make mistakes in the short run. We see the problems that come, the consequences of those mistakes when it comes to sort of what we're allowing. Uh, but then when those failures become visible and there's sufficient understanding, I think I'm optimistic that we do um, end up pushing for regulations or pushing for changes in the way things are done and they get sorted out. But there's this long period of time before that happens, right? And um, I think it's something citizens should be made more aware of and have conversations about. I think there's also a challenge with respect to education to some extent, right? There's a sense that like, oh, this technical stuff is just for the engineers,
Mm-hmm.
and everybody else will deal with the political and the social things. But it's not like that, right? In some sense, the engineers that understand things more deeply need to help inform the broader public. The broader public needs to know a lot of, at some level, how these systems work so that they can think about what their implications are for themselves and be able to engage in reasonable debates about it, I think, and then, vote based on their understanding of it. So I think that's something we are still at the very early stages of building this kind of a society where there's a lot of education around technology and its uses and abuses.
Yeah, I think technology has been a black box for people that are not in this space, but I think AI has done a really good job in trying to democratize the knowledge around that.
Yeah.
And you've described the space as flying an airplane while building it. So does that still feel true today?
I think that's always going to be true
Yeah.
of so many technologies that, particularly, in the recent years, whether it's blockchain, whether it's IoT, AI, that we're still figuring out what these things are capable of. And we can't wait till we figure it all out before we deploy them and use them. So we have to kind of adapt on the fly. And it's okay to be skeptical of technology. It's okay to be pushing back on some of it. But I think it's also okay to be optimistic and excited, and because that's also what brings up the solutions to the problems that we encounter. And I do think that it's an airplane. We're gonna fly it, and it is still under construction. Yeah, absolutely. I think that's true.
Yeah. And I think the space can be kind of overwhelming at some times because there's something new coming up every day. How do you stay up to date and just keep your skills fresh being in this industry for so long?
Yeah, I think it really helps that I'm at a university. It's a place that really encourages and thrives on the free exchange of ideas. We're constantly reading papers by our colleagues in the research domain. We're encountering them at conferences and meetings. We are working with students who are always coming in excited about the latest thing, and I'm always going, "Look, what is this new thing you're excited about? Let me learn so I can keep up with you." So that's a big part of it. I do think that the pace of new developments is so fast that it does feel, to me, increasingly like just trying to drink from a fire hose. And so, yeah, you drink a little bit here and there, and you hope you're getting, something that's uh, informing you, and you're continuing to learn, and you're able to also at the same time. And for me, particularly as a researcher, it's important not just to keep up with the latest developments, but to actually understand them at some level of depth to be able to contribute new ideas, to be able to develop new technologies and use cases and kind of reason about them. So but I feel like, in a way, I'm very fortunate to be in academia, to
Mm-hmm.
be a researcher, to be a professor, to be able to connect with students and peers, and kind of it helps slow down a little bit what is otherwise a very rapid change.
Yeah, and I think I've also seen you apply some of the changes where you make the new websites using Claude Code, and those have been really fun ways to learn. And also seeing how professors use AI to code. And that's like really refreshing to see because obviously as kids our age, we're just getting into the space. We need to understand how things work in the deeper level, but also it's good to see how fast things are moving and kind of keep up to date and see where the level of advancement is at.
Yeah, I mean, it's very important to just kind of keep up with these things and
Yeah.
try them out for yourselves, right? And yeah, I think that's also something that I'm always looking for ways to improve whatever it is that I'm doing. So, like, yeah, in a teaching setting, what are ways in which AI tools can help improve the experience for students? I think it's something that I'm always curious about.
Yeah, very cool. Um, Now switching gears to AI sort of meeting the physical world, there's been reporting on AI systems being too powerful. For example, recent Anthropic's model Mythos. What does that signal to you about where things are heading?
Yeah, that's a very interesting development. I feel like it's a signal that our AI model capabilities have crossed a threshold where the responsible thing to do is actually withhold sometimes the engineering system from deployment. Um, I think it's also a signal that, this technology is very much two-sided, right? The same technology that's very good at catching these vulnerabilities and helping us secure them in the wrong hands is an offensive weapon,
Yeah.
right? That can be used to exploit software systems. And so I think they probably made the right call in kind of being very careful about how it's deployed and who gets to deploy it first. But it's also a signal to all of us that I think we do need to be thinking about what are the safeguards and the guardrails that we need to put in place.
Yeah. I think, yeah, Anthropic definitely made the right choice by doing that. And also, when AI moves from software into physical systems, homes, cities, infrastructure, how does the risks change?
Couple of things, right? If we deploy AI and these systems into critical
Hmm.
infrastructure, into our homes, things that impact, right, our everyday lives, the cost of failure becomes very high. So the emphasis on reliability and security and fault tolerance is much higher than it used to be, right? So I think designing these systems from the get-go with security in mind is very important, because the impact of sometimes cascading failures, like some system fails and that causes something else to fail, and that causes
Hmm.
something else to fail. We see this, in, for example, classically, even in sometimes you get these grid failures on the
Mm.
energy grid, and one part of it collapsing increases the demand on another part, which causes that to collapse, and so on. So really, developing the tools for analyzing these complex systems and understanding these more complex failure modes, and as much as possible designing these systems from the get-go to avoid them.
Mm.
But also, failures will happen. We know that historically.
Hmm.
So to be able to understand them and fix the problems quickly and kind of iterate is also very important.
Yeah, makes sense. And sort of looking at the failures from a physical aspect, I recently was in SF last weekend where we visited a robotic startup. So they were talking about how they're sort of training the robot to do things in like factories. And the engineer was like, yeah, this robot has almost killed me multiple times because of how fast and strong its arm is.
Mhm.
So yeah, it's just like you can see how like even in the physical aspect, like these things
The
can
capabilities are
capabilities.
so,
Yeah,
yeah, alarming in some level,
yeah.
right? Yeah.
So that was scary, but obviously they're not going to deploy it until it's safe. But even then, you never know. Um, and as AI starts coordinating entire networks of devices, how much autonomy do you think is too much?
I think, as a background, when I started at USC, I named my research group the Autonomous Networks Research
Mm-hmm.
Group because I could see a future that we were moving towards already, 20 years ago, where the ratio of devices to humans was increasing exponentially. So from just having one smart device to having 10 smart devices that you control to 100 or maybe even, three orders of magnitude more than the number of humans is kind of where things have been headed. And at that kind of scale, you just cannot have a human manage, deploy, fix, maintain every device that's out there. So the devices have to, the networks have to some extent, autonomously manage themselves and secure themselves and update themselves and reconfigure themselves and so on. So I think in a way, because of that trend, autonomy is not really a choice. It's something we are going to have to do. But at the same time, as with all technology, it's really there to serve us and not harm us, which means that we do have to build in guardrails. We do have to build in safety measures where the autonomy is not unfettered. There are checks and balances. There are ways to build in trust. And there's also a need to make our systems much more explainable and transparent. So the more complex they are, can they kind of explain to us what they're doing and why? And when there are particular decisions to be made that have potentially safety consequences, that there is a human in the loop in those decision points. So I think this is still something we're getting the hang of as we're building more complex systems. But I think autonomous systems will have to be built with a lot of care in that sense. Yeah.
Makes sense. And is there a concrete example that you've worked on something in your research group where you've have to where you've implemented that?
So I guess good examples would come from some of the network security type of things. So we worked a few years ago on a project for detecting distributed denial of service attacks on networks from IoT devices. So as we have these thousands of IoT devices, it's very easy for them to have been deployed in an insecure manner that someone can basically guess the password and hack into them. And if they can take over large numbers of IoT devices, they can use them to launch attacks on other servers, bring them down, and affect their availability. So we were building essentially autonomous detection systems that leverage machine learning and AI tools to be monitoring the network activity to understand when patterns are anomalous, when they are, the data being sent from sources suggests that this is very unusual behavior for these devices. And in those cases, essentially to shut down the nodes that look suspicious, or at the very minimum, kind of flag this activity for a human operator to be kind of paying attention to and either override and say, no, this was, kind of expected behavior because something has changed in the application, or because, or indeed, this is really unusual and needs a second look. So, so this is an idea where the autonomous operation of the network is focused on securing the network, right? And so, building in these safeguards where the networks are not just operating themselves; they're also securing themselves autonomously.
Makes sense. And is there a human in the loop that shuts it down, or is it sort of that part is autonomous where it shuts it down itself?
That's kind of open to
Okay.
implementation to some extent, and it has also to do with how much you can rely on the
Mm-hmm.
decision making capabilities of the AI tool. I think there's probably some natural cycle where initially you want to put a lot of safeguards until you build trust in the decision making capabilities of
Mm-hmm.
the AI tool. Actually, we see that these days even with Claude Code, where by default, every time it wants to do something, it'll ask you yes or no, and you have to actually read it and say yes. But for most users, once they've got the hang of what it
Mm-hmm.
can and cannot do, they'll basically go to the dangerously skip permissions mode and kind of run things. But often by that time, they've got a good idea of what it can and can't do. So in my case, for example, I also installed some additional skills that and hooks that are basically there to prevent it from doing certain actions on my
Mm-hmm.
computer that I know are going to be unsafe. And so I want both that peace of mind that it's not going to do something unsafe, but I also want a little bit more hands-off mode so that it can do long-running tasks without my having to be there and hit, yes, every second. Actually, another quick example, if I
Yeah,
can
of course.
sneak it in. My very first experience in an autonomous car was in 2007, which is years before they got deployed. And this was on the GM campus, and it was an R&D facility, and they were demonstrating for one of the early DARPA challenges, this car kind of going to park itself in the parking lot. So I sit in the back. The car's driving autonomously, but on the passenger seat was a sort of anxious engineer with his hand on a laptop, which was basically going to be the kill switch in
Yeah,
case something went awry. So we came a long way from there to
yeah,
now my being able to take Waymo rides where
yeah,
there's, absolutely no driver, and I can kind of relax and do my thing without worrying about safety. So I think there is that natural progression, right? So it's
yeah.
taken 20 years for us to get to the point where we completely trust that this car, by and large, is safe, right? And despite being autonomous, so I think there's going to be a similar kind of journey in all the systems that we build.
Yeah, and these systems are increasingly learning from humans. An example that you gave was, for example, Waymo uses imitation learning and reinforcement learning, and how the Waymo like swerved a part of the road when there wasn't even anything there, and that could have been from like a past instance where a driver did that,
Hmm.
and at that time there would have been something there. So, yeah, like these systems are increasingly learning from humans, and that's a prime example of that. um and if you were a student today, what would you focus on?
Um, there's just so much.
Yeah.
I feel like it's an exciting time as at least an engineer or someone interested in technology because there's so much happening, so much to learn. Not just AI, but there's quantum computing. We're getting closer to understanding how the human brain really works. We are developing all kinds of new privacy preserving technologies like zero knowledge proofs and so on. I would say for students, it's very important to see what is the thing you're most passionate about, what attracts you, what grabs your attention, and energizes you, and kind of channel your energies in those directions. And it doesn't just have to be technology; it could also be about its uses, its applications. What are the applications that attract you as an individual? Is it education? Is it sustainability?
Hmm.
Is it just making people's lives easier? Healthcare and so on. So kind of like as a student, it's very important to kind of explore things with an open mind, but also, build your own internal radar for like what are the directions that kind of pull you and why, and kind of yeah, go in and go all in and just pursue it and learn and master and try things out.
Yeah, that makes sense. I transferred to USC my sophomore year, so last year, and I think I've tried to explore so many different clubs on campus, research groups. I also recently switched from CS to CECS, partly because I was scared of the AI capabilities and how it's so good at software now. So it can be a little bit demotivating for students. So, what are your thoughts on how good AI is, and should I even like learn CS still?
Mm-hmm.
And I think obviously robotics has not reached that level yet where it can like do embedded software just as good yet. Um, so yeah, where should people head, or should people still do software? Yeah.
Yeah. I think there are certain things that AI is going to get a lot better at than humans. And at this point, it's clear that software development and just coding a solution to a well defined problem is one of them.
Mm-hmm.
But defining the problem and shaping the tool to help you build something meaningful that other humans care about, want, that have the right guardrails in place. I think those are all things around the actual core functionality of writing code
Mm-hmm.
that is, to my mind, not changing right away. Um, I also think places where the technology interacts with the physical world, with humans, those are all places that we're going to see a lot more room for humans to be involved in and engaged with. I also think, if you think about anything to do with building the infrastructure for compute, things that have hardware in them, things that get down to devices, materials, energy. These are all topics where there's a lot of room for innovation. I also think computational thinking applied to all kinds of domains,
Mm-hmm.
from business supply chains to healthcare to even agriculture to different use cases. That's a very valuable skill. So I think what people should be looking to get out of a CS degree, if they want to pursue it, is not learning to code in Java so they can get a particular job to do coding. They should be looking to train their critical thinking skills, their computational view of the world, understanding what algorithms are at their core, what systems can and can't do, what does it mean to evaluate reliability and robustness and safety. These are all things you could be learning, right? And that's not just this mundane thing of like, implementing a particular piece of code. So I think there's going to be a change in emphasis in what it means to be a computer scientist. Is not just a coder, it's understanding computational systems from every aspect of it, like networking and sensing and robotics and actuation and control. All of those elements are much more than just a piece of code that an AI can do for you.
Yeah, no, that makes a lot of sense and gives me some hope. And just kind of wrapping things off, what's an important problem in this space that you think isn't getting enough attention?
Um, I would actually say, the developments with AI are opening up new possibilities, and our immediate go-to reaction for natural reasons is sort of the fear about what it's taking over,
Mm-hmm.
right? What it's taking away from us, opportunities. I think what is not getting enough attention, perhaps in that narrative, and it's not true for everyone, I think there are people on the other side of it as well, is okay, so we have these new capabilities. What can we do now that we could not do before?
Mm-hmm.
What are new economic opportunities we can create? What are new fields that previously we felt were just too expensive to try and do, but now because the cost of trying out ideas in software has dropped so much, we might be able to do? Can we build computational models of physical systems that allow us to do much more capable things in the world of medicine, in the world of chemistry, and so on. So I think what is not getting enough attention is sort of like getting past that initial reaction of this is changing my world in a way that I'm uncomfortable with and it seems unsettling, to how do I shape the world to be better, to help us thrive, leveraging the new capability that's emerged. And I think we've always done this. I think we have succeeded, in various times, kind of just adapting to what we have now as a capability and then using it, using the productivity gains to kind of open up new opportunities. Um, at the same time, there can be a lot of upheaval and social disruption when these things happen. In the industrial age, there was a large period of de-skilling where people that had kind of a lot of hands-on skills were no longer needed because machines could do it much faster and in a mass-produced way. But we kind of emerged from that in a way stronger with an economy built around automation and large-scale production. So I think maybe what's not getting enough attention is sort of how do we harness all this to kind of move on to that next stage and at the same time mitigate some of the disruptions and harms that we might see in the short term. But I some part of me is just always very optimistic about engineering giving us a way to address the challenges that we encounter. At the same time, I think we need to work with people that are not engineers to make sure that we have the right checks and balances in place politically, socially, from a governance standpoint. And then also just, individually to really think about like, what are the uses of technology that, help us thrive?
Yeah. And a couple or like a good amount of years ago when the internet became a thing, I think that only gave us a lot of opportunities. And obviously, there are pros and cons to every technology, but if we use it for the good, I think it can be really helpful to humanity. And this will be our last question, but after 20 plus years in this space, what still excites you the most?
It's just the constant emergence of new topics that, there's never a day where I can say, oh, I've learned it all. I'm done,
Yeah.
done learning. So I think what excites me the most is just learning new things and being able to share that with colleagues and students and learn from them. So yeah, I'm still very excited about this, everything that I do.
Well, yeah, this will be all. Thank you so much for joining us. And it was a really fun conversation, and I'm sure our audience will really enjoy it. So thank you so much.
Thank you, Aditi. This was great.